let's answer our third area under the curve question when we're interested in what is the probability of obtaining a mean between two means. So we'll go through 4 steps to help us answer that question. We'll start with step 1, but before we do that, let's revisit the example. So we're saying if 100 scores are selected at random from a normal distribution with a mean of 30 and a standard deviation of 10, what is the exact probability that the mean of these 100 scores will be between 28 and 32? So let's highlight what we need in this problem. So we have 100, which is how many, our sample size in this case. Our population mean is 30. Our population standard deviation is 10. We have a mean of 28 and a mean of 32. And then we're interested in what is the probability between these two values. So those are the relevant details to help us answer this question. Step 1, we want to compute standard error once, and then we're going to compute 2 z-scores using the formula. So we've computed the standard error in a previous video, but let's do it one more time. So the population standard deviation is 10. The sample size is 100, so it's 10 divided by the square root of 100, and the standard error is 1. So to make a distinction between the two z-scores, the smaller of the two z-scores is going to be z1. So that will be the smaller of the two means that we're transforming into a z-score. So that is 28 minus the population mean of 30 divided by the standard error that we computed up here. So 28 minus 30 is -2 divided by 1 is -2. That's our z-score 1. Now we need to transform our mean of 32 into a z-score. So that would be 32 minus 30 divided by 1, and that's +2. So those are our two z-scores, and that's step 1. Now in step 2, we want to locate our z-scores in our standard normal distribution, and we shade in between those two z-scores. So the z-score 1 is 2 standard deviations below the center, so it's -2. And z2 is 2 standard deviations above the center, and so that's a z-score of 2. And what we're interested in is this huge part of the distribution that's between these two z-scores. So in order to determine that, we want to look up z-score 1 and z-score 2 in the z-table. So first we'll start with our negative z-score, -2. So let's go to our z-score of -2. So the first column all the way down to -2, and then first column here, so that value is 0.0228. So that's our z-score 1 probability is 0.0228. And then we'll go over to the positive side, and we'll go to our z-score of +2. So we'll go all the way down to 2 and over to the first column, and we see that value is 0.9772. So that's for z2. So what we understand is that that proportion or probability below a z-score of 1 is 0.0228. So that really describes, let me just get my red pen here. That describes this area right here. That's what this value, oops, let's try this again. That describes this value here. So that's that little tail right here. And then the proportion below z2 is everything from this z-score all the way over to the end. So if you can imagine, we just shade all that in. And that's not really what we're interested in. So we want to get the difference. So when we're looking at computing what's between, we're taking the larger amount, which describes everything from the z-score below, and we're subtracting this little area right here. So we're taking 0.9772, which is this value, which is everything below z-score 2, minus this little tail, and what we end up is 0.9544, which describes what is between. So once we take the total area below the z-score 2 minus whatever is in this tail, what we're left with is what's between those two z-scores. So then we can report our z-scores, what the probability of obtaining a mean between these two means of 28 and 32. And we would say something again using the sort of template form. The probability is p equals 0.9544, which is the final proportion that we computed, the difference between z-score 1 and z-score 2's probability values, that a random sample of 100 scores will have a mean of 28 and a mean between a mean of 28 and a mean of 32 when drawn from a normal distribution having a mean of 30 and a standard deviation of 10. So that's our probability of obtaining a mean between two means, area under the curve question. In our next video, we're going to be answering our last area under the curve question when we're interested in what is the probability of obtaining a mean outside of two means.